we've evolved under very broad spectrum sunlight for millions of years. In fact, life has evolved under broad spectrum sunlight for billions of years. And then we had firelight, and that was pretty much the same as sunlight. And then we had incandescent light bulbs, and that was pretty much the same as sunlight. And then we had LEDs. And the thing about LEDs that people don't realize is it took away all the light that you couldn't see, but that your body detected. So it took away all the light that generates vitamin D, which we're all aware of. It's what gives us sunburn. But it took away all the really, really, really long wavelengths into the infrared, which again, we don't see, but are pretty fundamental for our health. Now, I was aware of this, but then I slowly became aware of increased incidences of disease, problems that might be occurring because something had been taken away. It's become an awareness of a disease of absence. One of my colleagues calls it modern scurvy, because there are not many diseases that you have which arise because something is taken away from you. Scurvy occurred because sailors at sea for long periods of time got no vitamin C and their body started to fall apart. But the moment they consumed plant matter or fruit, they improved dramatically. So the issue is it's a disease of absence, and we're only just beginning to be aware of it.
Do you think there has been a pivotal point when light became a real issue for health from your perspective?
I think there are so many small ones that identifying an individual pivotal point is very, very hard to define. It's synthesizing and putting together all these stories that are coming at you from a different direction, and you start to develop a bias, and you start looking for the obvious. Why are some diseases increasing in the way that they are? That was something that really me. So at the same time as we've got an absence of longer wavelength light, we ourselves as a population are aging much longer. So we're being exposed to diseases now, like dementia is a disease which, to a first approximation, didn't exist 300 years ago because you were dead. So now we've got a disease which is expanding in an aging population. And many of us feel that one of the things that is driving that is inappropriate lighting, because the lighting that's been taken away, we know works to regulate metabolism and a lot of the processes that occur in the brain. A really good example is also diabetes. Diabetes is when your blood sugars go up, and these things in your body, your mitochondria, they are things that eat sugar. They consume sugar. They also look at the light all the time. So when you slow them down, which is what happens under LED lighting, they stop eating. And when they stop eating, your blood sugars go up. And when your blood sugars go up, you become pre-diabetic. So one of the things that we've done is we've used long wavelength light to improve your blood sugars. And that is very clear, and that is very obvious, and it doesn't involve any injections. It doesn't involve taking any tablets. It's just light.
The Industrial Revolution came along around 100 years ago plus, and we all started working inside in factories. We moved from agriculture into factory work. And then that turned into the knowledge work ecosystem after the Second World War, where everyone started working in offices and indoor spaces. Do you think red light started becoming an issue and we weren't really aware of it for, say, at least 100 years because we were living in these indoor environments? I mean, of course, there was tungsten light then, but do you think that the closed environments then already started creating an issue for human health span?
Yeah, definitely. But the problem is we weren't looking for it. There are so many things that you identify as a problem that fundamentally are not a problem. And there are so many things that you see that are problems that you don't identify. There wasn't a culture for looking at light and seeing light. Okay, you get certain people who say, oh, as we're treating TB, wheel people outside. But that's was viewed as a rather primitive thing. And so it got a lot of criticism and we dropped it. But actually, there may well have been something in it. Florence Nightingale said, one of the best things you can ever do, that one of the best forms of medicine is daylight. We're coming back to that point of view now. Parkinson's disease, dementia, diabetes, etc. These were not common diseases 150 years ago. So the disease pattern changes in an aging population, and so we look to different things. There was a great example of macular degeneration. Macular degeneration was very rare in Japan before the Second World War. After the Second World War, with fatty diets from American soldiers come in, macular degeneration takes off. So diseases occur because something happens, your environment changes, and something happens, and this suddenly appears, and we don't recognize it.
So we're just playing with ideas here. So could the rise in macular degeneration in Japan after the Second World War be attributed possibly also to a lot of indoor office work, because their knowledge work economy, of course, expanded after then? So could that have also contributed?
Yeah, and there's a lot of variables here. So I think what you need to do is go and look at 53 different cases in different situations and say, is there a common thread here? Is there something here which is a bit of the jigsaw puzzle we hadn't seen before? And I think that's really important. Move away from a very tunnel vision approach to looking at what's happening either side of you. And when you're moving in this environment, make sure you're surrounded by your enemies and not your friends, because they'll be the best critics of what you're doing.
This is the best advice you could give for everything, actually, not just this. You had that great study where putting red light on a patch of skin on the back led to improved color vision, which is extraordinary if you think about it, because you're putting light on the back. How do their eyes get better? Which is an astonishing finding. Could you tell me a little bit more about that experiment, and also what you think explains the findings?
Okay, so if we look at the eyes, first of all, the eye ages faster than any other organ in your body. It burns energy. And I use the analogy of a car. A sports car uses a lot of energy, but a sports car doesn't last very long. Ford Cortina doesn't burn much energy, and it lasts too long and you get fed up with it. So our eye is a threatened environment in aging because it burns too much energy. But the things that burn energy, the mitochondria, are all around the body, including the eye. Our vision is really dependent on mitochondria, but they act as a community. So I can shine red light on the eye, particularly in someone who's aging, and there's no question I can improve their color perception. Others have done it. It happens relatively quickly. It's relatively simple. The sad thing is people very often don't know that their color perception has improved unless you test them and show them the results.
And is this color in terms of all color?
Well, we tend to use certain color domains like blues and reds because it's relatively easy. If these mitochondria are talking to one another, then it's quite possible for us to, in theory, shine light on the foot and get an improvement in the eye. So we didn't shine it on the foot, but we shone it on people's backs. And to make sure they couldn't see it, we wrapped their heads in silver foil. So the only way the light could be communicated was via mitochondria talking to one another across the body. Very clear, happened, big improvement. In this case, 24 hours later rather than 15 or 20 minutes later. Took a bit longer, but it was very, very clear. And those experiments we've done with flies, we've done with bees, we've done with mice, and they're all exactly the same. Exactly the same.
So if we're looking at mitochondria and you found these really astonishing results with color vision, can we extend that to the optic nerve at all? Do you have any data? Do you know anything about its effects on the optic nerve? So
we know
glaucoma, optic neuritis, all of these things.
Yeah. So as far as glaucoma is concerned, glaucoma is a disease where the peripheral retina dies, complex reasons. Red light, and the mechanism behind this is very clear. Red light reduces the probability of a cell dying. And that was originally shown when they injected alcohol into animals' eyes and then gave them bursts of red light, and it was highly protective. We also know that you lose lots of cells through aging in the eye, and we know that red light is very, very protective there. It doesn't stop cells dying, but it reduces cell death. So we've never tried glaucoma. I have relatively little doubt it would work, The problem is you'd have to do it over a really long period of time. You'd have to do it over 10 years. I won't be here in 10 years' time. Someone will get around to doing it. The groundwork is there. Someone will get around to doing it. We've certainly got a great study that's coming out on uveitis, where we've reduced inflammation in uveitis. And in fact, that was done about 12 years ago. And it's only now that we've gone, hang on, this all now makes sense.
You've described previously how when we talk about red light in terms of it being beneficial, it's quite narrow minded to just look at one wavelength. In your view, really the entire sort of spectrum of red going into infrared has the potential to be beneficial. Some segments within that have been well studied in the past. That's why there's lots of data. But the a very wide portion of that spectrum is likely to be beneficial. You also have said you have noticed some things about timing. So the data on improving color vision, I think you found that giving this light in the morning was more beneficial than giving it in the afternoon.
Yes, definitely.
So
Definitely.
do you think circadian alignment is a factor here?
Yes. So mitochondria know the time of day. They know the time of day. And here's something really interesting about knowing the time of day. We do all these experiments with cells in dishes, and we do them in incubators. The cells don't know what the time of day is. So if you don't know what the time of day is, how do you expect the cell to respond appropriately to pharmaceutical agents you might give it? Right? So there is the only time a cell in a dish in an incubator sees the time of day is when the experimenter takes it out, puts it under an incredibly harsh blue light and changes the food and puts it back in again. We've got this drug that can remove amyloid beta. You put it into patients and they get worse. Look back along the disaster trail. Okay, because the disaster trail may have fundamental issues at its root, such as what was the time of day? Did they see light? Did they know the time of day? Were they just very confused?
So time of day is one of those things that's so easily missed and has potentially been frequently missed, actually. You're so right.
It's just not thinking things through properly. The mitochondria in one of the cells of your body knows what time of day it is.
There is such a giant leap between a real world setting and, as you say, a lab setting. From what you've seen, specific wavelengths are less important than red light in general. Is that right?
Yeah, that's true. So if we give a wavelength, and we don't give a specific wavelength, so you're going to do that really with a laser. You give a range, a restricted range. That's a really good sticking plaster for a problem, but it doesn't get rid of the problem. So if you actually give broad spectrum light, so not one little range of red light, but a whole wide spectrum of it, you get a much bigger effect. So the mitochondria are in a poor state. You drag them out and you give them this burst of one limited range, and you pick them up and they're okay for a while. Efficacy, you're going to get much better efficacy if you actually do this with a broad spectrum. And that's something we're just beginning to find. And that's why we're going back looking at incandescent light bulbs, broad spectrum light. And then people say, well, you touch it, it's hot, we're wasting energy. You're not wasting energy because actually that light is going through your body and your body's using it to bolster your mitochondria. Everything about mitochondria and light is really about balance.
Yeah.
Go outside, go into daylight, you will find the balance that your mitochondria have learned to live with for billions of years. When people say we've got this red light device, I say, go for a walk in the park. Just go for a walk to work.
So you've said, don't bother with a red light lamp. Get a dog.
Get a dog. Get a dog. It's the best thing you can ever do. Get a dog.
So a cloudy day. So we're in London this very, very cloudy October day. It's cold. It's grey.
It makes no difference because you're getting the same amount of red light. The only difference is as it goes through clouds, it scatters. That doesn't matter. We know we get a lot of red light from reflections from trees. Okay, in winter, there are far fewer leaves around. But the point is that a cloudy day is almost as good as a raw blistering sun in front of you. There is the sun is still giving off infrared. Remember, infrared goes through your clothes. It's not going to bulk at going through a cloud. It's just going to scatter. It's going to change its direction about.
So even if it doesn't feel warm and it
That doesn't
look
matter.
red or sunny,
No,
it's
doesn't
still
matter.
okay.
Yeah.
Okay, so let's move to today and the way we all work in indoor spaces. I remember you mentioning that you can't simply replicate outdoors by putting a series of different colored LEDs because the body or the mitochondria don't like individual bumps. They like
No,
a
they don't
nice
like it.
smooth curve.
Yeah.
So actually daylight, you say, is much better than having a whole range of LEDs. What else can we do? You work in an office, you can't really change the lighting in the ceiling. What can you do in your desk space or around you?
Well, you can get devices. You can get small devices. They are just going to be a sticky plaster. I'm regularly pushed by companies who want to push devices, and I have never found anything that is as good as walking out in sunlight, and nor should I. In terms of evolution, I should not find anything better.
Yeah.
You
Yeah.
know?
One of the things that I find really fascinating is that before I knew anything about ophthalmology, I used to always wonder why everything looks red when you close your eyes and you put your face towards the sun, first thing in the morning, especially. Later on, it becomes too strong. And then I realized that, of course, the eyelids block UV light.
Yeah.
So when you close your eyes and you face the sun early in the day when it's not too strong, the red light that comes through your eyelids is actually pure red light. It's not simply just the reflection or anything to do with the vasculature.
So certainly walking in the mornings when your mitochondria are receptive to this is probably, it's the best idea that you can have. So again, early morning walk with a dog.
Get a dog.
You get the answer to all health problems is get a dog.
That's absolutely fascinating. And also it's so interesting that we spoke earlier about how actually many eye doctors here in London, I was one of them, in Moorfields, we all work in these closed environments, and getting a little bit of the early morning sun on the way to work is really beneficial. Now, it's very trendy to have red light lamps, and people have red light saunas, and I know lots of people who use these lamps towards the end of the day. Is that beneficial?
I don't know. And there's a bit of we need to find this. My data would argue against it.
But it's not dangerous either.
Oh God, no, it's not that. The one thing about this red light issue, and I'm not saying this about all devices, I'm certainly saying it about the devices that we've worked with. All they are is an element of sunlight given to you at a slightly higher level. Even when we've been getting ethical permission to work on kids, the ethics committee look at ours and they go, it's completely safe. Right? So certainly the levels we administer at is completely safe. I suspect most red light devices are within the safe range, but they're not marked as medical devices, so they're not governed that tightly. And one of the annoying things is all these devices coming out all over the place, and people say, Glenn, can I use this? And I say, I've not pulled that apart. There was a time when I started pulling things apart. I was shocked at how cheaply the bits were that were inside it, but I can't spend my life pulling things apart. Don't go and spend $4,000 on a light that actually costs about $50 to put together. And that is going on a lot. We've had so many in here to test, and what I end up doing is generally give them away to people in the general office. It's great. You get £4,000 or £5,000 for the light.
It's a great place to work as a lab. Anyone looking for a lab assistant position, come and work here. What red light seems to do is it increases the production of ATP. So it increases essentially movement along the oxidative phosphorylation chain, resulting in more ATP generation. And I loved how you described how what that actually does is it does increase reactive oxygen species a little bit, but enough to send signals to create more of the complexes. But if there is too much reactive oxygen species generation, then in this long wavelength light, red light, infrared light, actually dampens that down. So it protects against too much oxidative stress, but it enables or it encourages just a little bit more reactive oxygen species to actually increase the resilience of the cell.
Yeah,
Is that correct?
That's absolutely correct.
So infrared has been shown to actually keep inflammation down.
Definitely. If the inflammation is caught early, right? So if we've got inflammation caught early, we're fine. If inflammation or a disease process has got its teeth into you, it's less effective. So we tried it on inflamed rheumatic hands, didn't do anything. But then later on, we realized if you catch that inflammation early, before you turn up clinically, you can have an effect.
Right. That is so interesting. So that means that actually doing it prophylactically, you will reap far more benefits than doing it once disease has happened. It's almost like a step change. It becomes too late.
Exactly. Absolutely.
And do you think this would also apply to neurodegenerative diseases, such as motor neuron disease, Parkinson's, Alzheimer's?
Definitely. So you catch it early. And it was certainly the case in Parkinson's, in the experimental models of Parkinson's. You leave a Parkinson model to run for months, it becomes unredemptive. If you catch it early, you've got a chance of moderating it. And that was exactly what we found with macular degeneration. When people had gone too far down the road, we had no effect whatsoever. When they're caught relatively early, before the central retina has degenerated, you get great results.